What makes you, you? Every day, we navigate our lives through layers of thoughts and feelings, all the while unaware that a massive enigma lies within our own skull. The nature of consciousness has baffled philosophers and scientists for centuries. Today, we embark on a journey to unearth the mysteries surrounding consciousness and how the human brain creates our sense of identity. Consciousness is not just about being awake. It's a complex tapestry woven from thoughts, emotions, and experiences. According to a 2020 study published in Nature, scientists found that consciousness might reside in specific brain networks rather than in one isolated area. But even with our advanced technologies, the exact origin of consciousness remains elusive. Imagine sitting quietly, your mind racing with thoughts, some fleeting and some persistent. A famous case study, the phantom limb syndrome, illustrates this complexity. Patients, often amputees, report sensations in limbs that no longer exist, feelings and consciousness extending beyond physiological reality. This suggests that the brain can create a sense of self that transcends the physical body. However, understanding consciousness raises more questions than answers. Is consciousness merely an evolutionary advantage, or is it evidence of a deeper purpose? Consider the life of Albert Einstein, whose brain was studied after his death. Researchers found that areas linked to mathematical ability were more densely packed with neurons, hinting at the brain's potential flexibility. What does this mean for the average person? Could it be that we all possess untapped potential? Beyond genetics, lifestyle plays a significant role in shaping our consciousness. A study published in the journal Frontiers in Human Neuroscience in 2019 indicates that mindfulness practices can enhance our awareness and, therefore, our consciousness. The brain's neuroplasticity allows it to adapt and change in response to our experiences, suggesting the power of our thoughts might be more influential than we realize. As we delve deeper into the genesis of consciousness, the implications of understanding it could redefine humanity's perception of self. Are we simply the sum of our experiences, or is there something more? This question hangs heavily in the air. We've only scratched the surface of understanding consciousness, and as we transition to the next chapter, remember this: if the brain is a realm of untapped possibilities, what might we discover next? Memory shapes who we are. Could you imagine a life without memories? It's through recollection that we form connections, learn from our past, and anticipate our future. Yet, the intricacies of how memory operates remain one of the great mysteries of the human brain. Memory isn't just about storing experiences, it's about the brain's ability to encode, store, and retrieve information. Neuroscientists categorize memory into three distinct types: sensory memory, short-term memory, and long-term memory, each serving unique functions. For instance, sensory memory is like the fleeting image an artist captures before it fades, a momentary impression of our surroundings. In a remarkable case from 2008, a man known as S., who lived in London, exhibited a phenomenon called hyperthymesia, where he could recall every single day of his life with incredible detail. Such rare talents shine light on how complex and sometimes puzzling human memory can be. One critical player in the memory process is the hippocampus, a seahorse-shaped structure nestled deep within the brain. Research has found that this area is vital for forming new memories. Yet, memory is astonishingly malleable. Studies indicate that recall can be influenced by our emotions, context, or even the way questions are framed. In fact, a groundbreaking study from 2012 showed that eyewitness testimonies could be altered simply by the phrasing of questions, leading to significant implications for our justice system. What we think of as crystal-clear memories can be as distorted as a cracked mirror. The deeper implications of this memory distortion raise questions about the reliability of our memories. If we reconstruct memories each time we recall them, how do we ensure the authenticity of our recollections? Furthermore, the concept of false memories poses a fascinating paradox. Experiments by Elizabeth Loftus, a prominent psychologist, have shown that people can recall events that never occurred, purely through suggestion. This phenomenon demonstrates the brain's power to create narratives, often leading us to question the essence of truth in our own lives. Consider an anecdote regarding childhood memories. Most people can recall their first day of school, yet the details vary significantly among individuals. What we remember can often feel less like a definitive account and more like a constructed story, shaped by emotional undertones and life experiences. This raises the fundamental question: are our memories reliable? As we grapple with this complexity, it is crucial to understand how memory impacts our identity and influences our decisions. In the next chapter, we will explore the role emotions play in memory formation and retention, revealing yet another layer of how intertwined our experiences are with our feelings. What if I told you that your emotions can physically alter your brain? Emotions are far more than fleeting feelings. They are integral to our survival and significantly influence our decision-making processes. The brain's emotional center, the limbic system, operates like a conductor, orchestrating our emotional responses and connecting them with memories. Research reveals that our emotional experiences can reshape neural pathways, creating patterns that can enhance or impair our functioning. For instance, in a study published in the journal Biological Psychiatry, researchers found that individuals experiencing chronic stress showed structural changes in the brain, particularly in the prefrontal cortex, the area responsible for decision-making and impulse control. This indicates a direct correlation between our emotional states and brain health. The implications of emotional regulation lead us to fascinating case studies. Take the story of Phineas Gage, a railroad construction foreman who survived a severe brain injury when an iron rod pierced his skull. Remarkably, he lived, but his personality changed dramatically, his ability to make rational decisions diminished, showing the profound connection between emotion, decision-making, and brain function. Moreover, emotional intelligence is a concept that has gained traction in recent years. It refers to the ability to understand and manage one's emotions and the emotions of others. Studies suggest that high emotional intelligence can lead to better relationships and work performance, highlighting the benefits of understanding emotions not just as fleeting responses, but as powerful tools in our lives. Neuroscience has shown us that the amygdala, often dubbed the fear center of the brain, plays a critical role in emotional responses. When triggered, the amygdala can initiate the fight-or-flight response, preparing the body to react to threats. However, what happens when this system is overactive? Conditions such as anxiety disorders and PTSD arise, demonstrating the darker side of our emotional landscapes. Therapeutic approaches such as cognitive behavioral therapy, CBT, have emerged to help regulate these responses, showcasing the power of understanding our emotions and their impact on our brains. As we navigate these complex emotional landscapes, it's evident that emotions can shape our reality. They mold our memories and influence our perceptions, underscoring the intricate relationship between feeling and cognition. In our next chapter, we will journey into the fascinating world of creativity and how it links with brain function, expanding our comprehension of what it means to think outside the box. Have you ever had a moment of pure inspiration? Creativity, often seen as the realm of artists and dreamers, is a vital component of human experience, intertwined with our cognitive processes. The brain's unique ability to synthesize information in innovative ways has led to groundbreaking discoveries across disciplines. One of the most profound discoveries in neuroscience is the concept of divergent thinking, which is the ability to generate multiple solutions to a problem. It is primarily associated with the prefrontal cortex, the area of the brain responsible for planning and decision-making. However, the relationship between creativity and the brain is multifaceted, involving different networks working in harmony. Studies show that engaging in creative activities can boost cognitive flexibility, allowing the brain to forge new connections. For example, research conducted in 2014 found that individuals who participated in improvisational theater exhibited increased activity in regions of the brain associated with social cognition and empathy. This connection between creativity and empathy suggests that the brain's creative faculties extend far beyond individual expression. They can enhance our understanding of others. Furthermore, the phenomenon of flow, described by psychologist Mihai Csikszentmihalyi, occurs when individuals become fully immersed in a creative task, allowing them to tap into their subconscious mind. However, creativity is not without its hurdles. Many creative individuals experience self-doubt, anxiety, or imposter syndrome, where they feel inadequate despite achievements. A recent study highlighted that artists often face mental health challenges, prompting the question, is there a link between mental health and creativity? Research indicates that the very traits that foster creativity, openness to experience, sensitivity, and emotional depth, can also predispose individuals to mental health issues. This intricate dance between creativity and mental health creates a complex relationship that seeks further exploration. As we examine this nexus, we realize that fostering creativity is essential for not only personal expression but also societal advancement. In our next chapter, we will delve into the brain's aging process, exploring how creativity and cognition change over time, shedding light on the potential for growth in later years. What happens to our brains as we age? The aging brain, an area of great intrigue, presents a paradox. While cognitive decline is often expected, there is also potential for growth and adaptation. As we grow older, synapses and neurons may begin to decline, but research reveals that the brain is also capable of remarkable neuroplasticity throughout life. It was once believed that neurogenesis, the process of forming new neurons, stops after a certain age, but groundbreaking studies have shown that it can continue well into old age, particularly in the hippocampus. In a 2018 study published in Nature, researchers demonstrated that older adults who engaged in regular physical and cognitive activities exhibited enhanced cognitive functioning, highlighting the brain's capacity for renewal. However, the aging brain is also susceptible to challenges, such as neurodegenerative diseases including Alzheimer's and dementia. The implications of these diseases on memory and cognition are dire, affecting millions globally. Studies estimate that by 2050, nearly 14 million Americans could be living with Alzheimer's. Yet, proactive measures can combat this decline. Cognitive engagement, social interaction, and physical health can all play essential roles in maintaining brain health during the aging process. As we learn how lifestyle choices can increase the odds of aging gracefully, the question arises, how might our understanding of the brain continue to evolve? Through this exploration of aging, we amplify the message that our brains, regardless of age, hold extraordinary potential. Where do we go next? In the next chapters, we will unlock further mysteries of the brain, focusing on its connections to technology and the future of humanity. Imagine a world where your brain could change its structure and function just by thinking differently. Neuroplasticity challenges everything we thought we knew about the brain's limitations. This incredible feature allows our brains to adapt, grow, and heal. The story of neuroplasticity is a story of hope and potential. The term neuroplasticity was not widely recognized until the 20th century. However, the seeds of this understanding were planted much earlier. In the 1900s, scientist Santiago Ramon y Cajal proposed that the adult brain was not static but capable of change. For decades, this idea was largely dismissed in favor of the belief that brain cells, or neurons, could not regenerate. But science has proven this wrong. A landmark experiment by Michael Merzenich in the 1980s showed that adult monkeys could develop new sensory maps in their brains after amputation. This work laid the foundation for understanding how experience shapes neural connections. Over time, not only did we learn about physical injuries leading to neuroplastic changes, but scientists also began to explore how mental exercises could lead to profound brain adaptations. Consider the story of a young stroke victim named Claire, who lost significant movement in her arm. Through intensive rehabilitation that included mirror therapy, where she visualized the movements of her unaffected arm while watching a reflection of it, Claire's brain began to rewire itself. Over months, she regained mobility. Her story illustrates the power behind neuroplasticity. Our ability to change isn't just limited to recovery, it plays a fundamental role in learning. Research by neuroscientist Barbara Oakley highlights how learning new languages or musical instruments can create entirely new neural pathways, enriching our cognitive capabilities. Oakley's TED Talk has inspired millions, emphasizing that the brain is more malleable than previously thought. Studies have shown that meditation can also promote neuroplasticity, especially in areas related to attention and emotion regulation. When we meditate, we not only calm our minds, but we also actively promote the growth of gray matter in regions of the brain associated with memory and self-awareness. What does this mean for aging populations? The World Health Organization reports that by 2050, the number of people over 60 will outnumber those under 15 for the first time in history. Neuroplasticity offers a beacon of hope, suggesting that even later in life, we can promote cognitive health through learning and adaptability. So, how can we harness this power in our daily lives? To take advantage of neuroplasticity, we need to step out of our comfort zones. Trying new activities, learning skills, or even simply engaging in thought-provoking conversations can effectively stimulate our brains. In fact, one study found that individuals who engaged in new and challenging activities exhibited increased cognitive function. Our brains are waiting for us to engage them. So, as we continue exploring the mysteries of the human brain, let us remember the boundless possibilities presented by neuroplasticity. What other secrets lie within our brains, waiting to be uncovered? As we delve deeper into the science of the brain, let's explore how the brain communicates emotions and how it plays a critical role in social connections. When we think about the human brain, we often overlook its role in social connections. The human brain is wired for relationships. Studies show that our social environment profoundly impacts our mental health and cognitive function. Recent research has unearthed fascinating insights about how our brains interact not only with ourselves but with the world around us. Your brain's social processing begins early, even in infancy. Babies are born with a predisposition to recognize faces. According to a study by Harvard University, infants can distinguish between different expressions shortly after birth. This innate ability suggests that social connection is a fundamental aspect of human existence. As we grow older, our social experiences shape our brain's evolution. Neuroscientist Matthew Lieberman has made significant contributions to understanding the social brain. His research indicates that areas of our brains, like the medial prefrontal cortex, are particularly active when we think about others. This part of the brain lights up when we consider the thoughts, feelings, and intentions of those around us. It suggests that social cognition is not just an add-on to our cognitive toolkit, it's a core aspect of our humanity. In a groundbreaking study conducted by neuroscientists at the University of Chicago, researchers found that humans have a specific neural network dedicated to social groups. This network responds to social information similarly to how we process rewards. Understanding social cues isn't just beneficial, it's crucial for survival. But what happens when social interactions are disrupted? A phenomenon called social isolation can have devastating impacts on our brains. A meta-analysis published in the journal Psychological Bulletin showed that social isolation can lead to increased risks of depression, anxiety, and even cognitive decline. The brain thrives on connection. Consider the incredible journey of John, a war veteran who faced difficulties integrating back into society after returning from service. Through connections with fellow veterans, he found not only support but also a renewed sense of purpose. His experience illustrates the profound impact of social relationships on mental health. Moreover, social media has transformed how we interact. A study by the Pew Research Center indicates that over 70% of adults use social media as a tool for connection. But while these platforms facilitate communication, they can also lead to an increase in feelings of loneliness and isolation. The paradox of social media underscores the complexity of our social brains. In conclusion, our brain is inherently social, and our relationships shape us, our thoughts, our emotions, and even our identities. As we journey further into understanding the brain, we must ask, how do these social connections manifest in our behaviors and experiences? Let's uncover the influence of the brain on our sleep cycles and how it regulates one of the most essential components of life, sleep. Sleep, it's the one activity we all partake in yet often take for granted. Behind closed eyelids, our brains undergo vital processes that facilitate health and well-being. But what exactly happens while we sleep? How does sleep impact the brain? Research over the past few decades has unveiled that sleep is not merely a state of rest, it is a dynamic process essential for cognitive function. During sleep, our brains cycle through several stages, including REM and non-REM sleep. Each stage plays a unique role in consolidating memories, processing emotions, and restoring energy. Consider this: during REM sleep, the brain is remarkably active. A study from Harvard University discovered that the brain is even more active during this stage than when we are awake. This activation not only facilitates creative problem-solving but also aids in emotional regulation. People who struggle with sleep often report heightened anxiety and emotional volatility. The mystery of sleep deepens with the concept of cleaning the house. Recent research suggests that during deep sleep, the brain's glymphatic system kicks in, flushing out toxins accumulated during our waking hours. This detoxification process is crucial for preventing neurodegenerative diseases like Alzheimer's. Without adequate sleep, our brains fall into disarray, making the connection between sleep and overall cognitive health more vital than ever. But what happens when sleep is disrupted? Chronic sleep deprivation is common today, affecting over 35% of adults in the United States alone. Studies conducted by the CDC reveal that poor sleep is linked to a range of issues, including obesity, diabetes, and cardiovascular disease. These physical ailments underscore the interconnectedness of our physiological and cognitive health. To illustrate how crucial sleep is for optimal brain functioning, let's explore the story of Sarah, an overworked nurse battling insomnia. Amid her demanding schedule, Sarah struggled to maintain focus and emotional balance. After seeking help and implementing good sleep hygiene practices, she found that not only did her work performance improve, but her relationships also flourished. Incorporating a consistent sleep schedule, avoiding screens before bed, and creating a calming environment allowed Sarah to reclaim her cognitive clarity and emotional well-being. As we move towards a resolution of our exploration, we must acknowledge the significance of sleep. The brain's intricate relationship with sleep emphasizes that it is not a luxury but a necessity. In our quest for answers, how does the brain process information, and what implications does this have for our understanding of reality? Let's investigate the neural mechanisms behind perception. The human brain is a master of perception. It connects various sensory inputs to create a cohesive experience of reality. But how does the brain transform raw data from the world into our perceptions, and how do these perceptions shape our thoughts and actions? Our journey begins with the senses. The brain receives signals from our eyes, ears, skin, tongue, and nose, processing this information with astonishing speed. The visual cortex, for instance, interprets light signals, while the auditory cortex decodes sounds. But this process is far from straightforward. Consider the fascinating phenomenon of optical illusions. Researchers have long used illusions to understand perception's complexities. An example is the famous Muller layer illusion, where two lines of equal length appear different due to the orientation of arrows at each end. Such illusions highlight the brain's role in interpreting visual stimuli based on context and prior experiences. The brain fills in gaps, often making assumptions based on past experiences, leading us to perceive a reality that may not necessarily exist. Moreover, our emotions dramatically influence perception. A study from Stanford University reveals that when people are anxious, they perceive ambiguous situations as threatening. This insight underscores how intertwined our emotional states are with our sensory perceptions, creating a feedback loop between the brain and our experiences. But perception is not solely tied to individual experiences, it also shapes our social realities. The way we perceive others can lead to biases and stereotypes. Research shows that individuals often make snap judgments based on appearance, which can lead to prejudice. Our perceptions, therefore, not only affect personal experiences but also the broader social fabric. To showcase the power of perception, let's examine the story of Maria, a woman who underwent significant changes after a personal crisis. Initially trapped in a negative perception of herself and her surroundings, Maria began practicing mindfulness and cognitive reframing. She learned to view challenges as opportunities for growth, leading to transformative changes in her life. As we draw nearer to our conclusion, let us acknowledge that perception is a powerful tool that shapes our behaviors, relationships, and experiences. Our understanding of the brain's perception mechanisms can unlock the secrets to personal development. So, what lies on the horizon for brain research? What new discoveries await as we venture deeper into the mysteries of the human brain? Let's explore the future prospects of neuroscience and what they hold for humanity. As we stand at the precipice of groundbreaking advancements in neuroscience, we must ask ourselves, what does the future hold for our understanding of the human brain? With rapid innovations in technology, the potential for discovery seems limitless. Today, initiatives like the Brain Initiative aim to map the human brain's complex structure and function. Launched in 2013, this ambitious project intends to facilitate vast improvements in understanding neurological disorders and the brain's fundamental workings. Researchers are utilizing advanced imaging techniques, such as functional MRI and optogenetics, to monitor brain activity with unprecedented precision. Moreover, the field of artificial intelligence, AI, is beginning to intersect with neuroscience. The development of neural networks, inspired by the human brain, has led to remarkable breakthroughs in machine learning and cognitive computing. As we draw parallels between human cognition and machine learning, we are challenged to rethink our understanding of consciousness and intelligence. The implications extend beyond technology. Understanding the brain's intricacies has profound ethical considerations. As we unlock the secrets of the brain, questions arise regarding privacy, consent, and the potential for manipulation. Neuroethics becomes more critical than ever. Let's reflect on a groundbreaking case, when researchers applied direct brain stimulation to enhance cognitive function in individuals. This intervention, while promising, sparked debates about the implications of altering human cognition and identity. As we tread these waters, the ethical responsibility towards individuals and society must remain at the forefront. As we look forward, let's also acknowledge that the future does not only focus on technological advancement but on holistic approaches to mental health. Integrative approaches combining psychological therapy, lifestyle changes, and medicinal interventions will pave the way for improving mental well-being. Countries like Finland are already implementing innovative mental health strategies, emphasizing the necessity of supportive environments for brain health. In conclusion, the future of neuroscience is not merely a journey into the unknown but a voyage into understanding our very essence as human beings. Each discovery unlocks a new layer of consciousness, redefining what it means to be human. So, as we end this exploration of the human brain's mysteries, let us continue to ponder our incredible capacity for resilience, adaptability, and connection. What wonders will our brains uncover next? As we embrace the mysteries of the mind, we invite you to join us in this captivating journey through the cosmos of human experience. Language is one of the most compelling aspects of human experience, yet its origins and mechanisms within the brain remain shrouded in mystery. The journey begins in the cerebral cortex, where areas such as Broca's and Wernicke's play pivotal roles in language production and comprehension. Studies show that around 95% of right-handed individuals have their language centers in the left hemisphere. But what happens when these areas are damaged? The case of Paul Broca's patient, known as Tan, offers profound insights into aphasia. Despite Tan's inability to speak more than one syllable, he understood language remarkably well. This stark contrast highlights how distinct neural pathways shape our ability to communicate. Furthermore, insights from neuroimaging reveal that using language activates a network of regions not only involved in speech but also in emotion and memory. This intricate web suggests that language is not merely a tool for communication but also a bridge connecting us to our feelings and experiences. But as technology advances, we are now faced with an astonishing question: can machines understand human language as we do? The narrative continues with a discussion on the evolution of language, a unique trait that sets humans apart from other species. Evidence suggests that our ancestors may have developed rudimentary forms of communication that eventually transformed into complex languages. The discovery of the FOXP2 gene, often dubbed the language gene, adds another layer to this narrative by emphasizing the biological underpinnings of our linguistic capabilities. However, the development of language is only part of the story. The social context in which language is used is equally critical. Investigations into the social brain hypothesis suggest that our linguistic abilities evolved in tandem with the increasing complexity of social structures. As we dive deeper, we explore the significance of bilingualism and its effects on brain structure and cognitive function. Studies indicate that bilingual individuals exhibit greater flexibility in problem-solving and have a delay in the onset of dementia symptoms. The chapter concludes with the intriguing advancements in artificial intelligence attempting to mimic human-like communication, raising ethical questions about consciousness and the potential for machine empathy. How will this shape our future interactions? Every day, countless individuals confront traumatic experiences, leaving indelible marks on their psyche and physiology. Trauma can arise from various sources: war, abuse, accidents, or natural disasters. The brain's response to trauma is complex and multifaceted. The amygdala, the brain's fear center, becomes hyperactive, while the prefrontal cortex, responsible for rational thinking and decision-making, may become underactive. This imbalance often results in heightened anxiety, hypervigilance, and intrusive memories. Consider the case of a soldier who returns from combat with PTSD, struggling to reintegrate into civilian life. Research reveals that traumatic memories can become fragmented and disjointed, making it difficult for survivors to speak about their experiences. Understanding the neurobiology of trauma is crucial. Brain scans of individuals with PTSD show reduced hippocampal volume, a region essential for memory formation. As we delve deeper, we encounter groundbreaking therapeutic approaches aimed at healing trauma. Eye movement desensitization and reprocessing, EMDR, therapy encourages patients to reprocess traumatic memories while engaging in bilateral eye movements. Studies have shown that EMDR can lead to significant reductions in PTSD symptoms, challenging traditional beliefs about trauma treatment. Additionally, emerging modalities such as psilocybin-assisted therapy are gaining attention, suggesting psychedelics may play a role in rewiring the brain's response to trauma. The chapter also sheds light on the concept of resilience, focusing on how some individuals manage to thrive despite their experiences. Neurological studies indicate that resilience may be linked to the brain's ability to adapt through neuroplasticity. But why do some individuals overcome adversity while others struggle? This question leads us into personal stories that illustrate the diversity of human responses to trauma, revealing valuable lessons about healing and recovery. What if I told you that your gut might hold the key to understanding your brain's health? This intriguing concept has emerged from a field of research exploring the bidirectional communication between the brain and the gut known as the gut-brain axis. With millions of neurons lining the gastrointestinal tract, often referred to as the second brain, this connection is more profound than many realize. Research indicates that the gut microbiome plays a significant role in mood regulation and cognitive function. In a world where mental health struggles are on the rise, scientists are investigating how altering gut bacteria through diet or probiotics may support mental well-being. For instance, a study published in the journal Psychiatry Research found that individuals consuming a diet rich in fermented foods reported lower levels of social anxiety. This scientific revelation challenges conventional approaches to mental health, emphasizing the need for a more holistic understanding of treatment. As we dive deeper, we look at the impact of stress on gut health and the implications for mental well-being. Chronic stress can lead to gut dysbiosis, contributing to conditions like irritable bowel syndrome and anxiety disorders. The chapter also highlights innovative therapies that blend nutrition and psychology, such as nutritional psychiatry, which advocates for dietary changes as a first-line treatment for mental health disorders. Some researchers are even exploring the possibility of fecal transplants as a means to restore gut health and improve psychological outcomes. Can this simple procedure revolutionize how we view mental illness? The narrative culminates with a glimpse into future findings that may redefine our understanding of health. As we uncover the science of the gut-brain axis, we unlock new possibilities for treatment and prevention. Imagine a world where tiny organisms living in your gut influence your thoughts, emotions, and decisions. This may sound like the plot of a science fiction novel, but the reality is that our brains are profoundly affected by our gut microbiome. Emerging research indicates that the 100 trillion microbes residing in our intestines play a pivotal role in brain health and function. The relationship between our gut and brain is often referred to as the gut-brain axis. This communication pathway involves direct connections through the vagus nerve, chemical signaling via hormones and bioactive compounds, and even the immune system. But how exactly do gut microbes communicate with the brain? One enlightening study conducted by researchers at the University of California found that germ-free mice, raised without any gut bacteria, exhibited altered behavior. When these mice were introduced to specific strains of beneficial bacteria, researchers observed improvements in anxiety-like behavior. This suggests that our microbial inhabitants could be key players in anxiety and depression management. Furthermore, certain gut bacteria produce neurotransmitters, such as serotonin, which is a chemical often referred to as the feel-good hormone. It's astonishing to learn that about 90% of the body's serotonin is produced in the gut. This means that the health of our gut could directly influence our mood and mental well-being. Moreover, the implications of this gut-brain connection stretch far beyond mood. Researchers have begun exploring the role of the microbiome in neurodegenerative diseases like Alzheimer's and Parkinson's. For instance, a study published in the journal Nature found that certain gut bacteria might be linked to the development of Alzheimer's disease. They observed that specific bacterial profiles in the gut of Alzheimer's patients differed significantly from those in healthy individuals. This opens intriguing avenues for new therapeutic strategies, potentially using probiotics or dietary interventions to reshape our microbiota for better brain health. But can the influence of our gut bacteria extend to how we think or create? Some psychologists believe that the composition of our gut microbiome might affect cognitive functions like creativity and decision-making. In an experimental setup, researchers found that individuals with more diverse gut bacteria performed better on creative thinking tests. This correlation hints that nourishing our gut could very well be a pathway to enhancing our cognitive abilities. As we delve into this fascinating area of research, we must consider how our modern lifestyles, filled with processed foods, antibiotics, and stress, impact our gut microbiome and, consequently, our brains. The next logical question arises: how do we optimize our gut health to harness these benefits? Incorporating a diet rich in fiber, fermented foods, and probiotics, alongside doing regular exercise, may all contribute positively to our gut health. A practical approach to managing stress, such as mindfulness meditation, might further help maintain the delicate balance of our microbiome. While the science is still in its infancy, the connection between our gut and brain highlights a remarkable symbiosis that could redefine our understanding of mental health. The mysteries of the human brain, it seems, extend far beyond its physical confines. As we step into the future of neuroscience, the gut-brain connection invites us to rethink our approach to mental health. While we don't have all the answers yet, the potential for a healthier lifestyle to directly improve brain function opens new doors in our quest for understanding ourselves. And just when we think we've scratched the surface, a new layer of complexity reveals itself, posing yet more questions than answers. What other secrets lie within the intricate workings of our brains? Every day, millions of people grapple with the effects of brain disorders, conditions that not only challenge their physical capabilities but reshape their very identities. These disorders, which range from Alzheimer's disease to schizophrenia, paint a sobering picture of how much we still have to learn about our most vital organ. Take Alzheimer's disease, for instance. It is the most common form of dementia. According to the Alzheimer's Association, more than 6 million Americans live with this progressive brain disorder, which disrupts memory, thinking, and behavior. Over time, patients can lose their ability to carry on conversations or respond to their environment. The journey through Alzheimer's is steeped in uncertainty, not only for patients but for their loved ones, too. What makes Alzheimer's so perplexing is the insidious nature of its onset. For years, researchers have sought to unravel the mechanisms behind the accumulation of amyloid plaques and tau tangles that characterize the brains of affected individuals. Despite decades of research, the exact causes remain elusive. Is it merely genetics at play? Epidemiological studies hint at a multifactorial origin, where lifestyle choices, environmental exposures, and genetic predisposition intertwine. One study from the Framingham Heart Study revealed that cardiovascular health is closely tied to Alzheimer's risk. Participants with high cholesterol and hypertension showed a significantly higher likelihood of developing dementia later in life. In contrast, those who maintained a healthy heart exhibited better cognitive outcomes. But there's more. The psychological toll of brain disorders extends beyond affected individuals. Families find themselves navigating a labyrinth of emotions, switching between hope, despair, and frustration as they watch their loved ones change. Consider the heartbreaking case of an individual diagnosed with frontotemporal dementia. This form of dementia typically strikes earlier than Alzheimer's, often in a person's 40s or 50s. Families report seeing their loved ones undergo profound personality changes, losing empathy and social awareness overnight. The stigma surrounding brain disorders also adds another layer of complexity. Individuals suffering from conditions like schizophrenia often face social isolation, misunderstanding, and discrimination. A report from the World Health Organization indicates that stigma leads to limited access to effective treatment for those afflicted, resulting in poorer outcomes. Yet, amidst this challenging landscape, hope continues to shine through groundbreaking advances in neuroscience. The discovery of biomarkers for early diagnosis is paving the way for potential treatments that could halt the progression of brain disorders before they take root. One exciting area of research involves the use of immunotherapy to clear amyloid plaques from the brains of Alzheimer's patients. Early-stage trials have shown promising results, leading to increased interest and investment in neural research. Additionally, advocates for mental health awareness and destigmatization are making significant strides in reshaping public perception of brain disorders. Campaigns promoting empathy, understanding, and support enable individuals to share their experiences without fear of judgment. The brighter side of this movement fosters a supportive community where individuals can find solace in shared experiences. While we may still be grappling with significant questions about brain disorders, the resilience of the human spirit in the face of adversity reminds us that there is still so much to learn and discover. And as we venture deeper into the mysteries of the human brain, each discovery could illuminate pathways toward treatment and understanding that we have yet to imagine, raising fundamental questions that continue to baffle us all. What is the essence of the self when the very brain that defines us is in flux? With the frenetic pace of modern life, the quest for inner peace has never been more urgent. Enter mindfulness, a practice rooted in ancient traditions that has garnered attention in neuroscience for its profound effects on the brain. But what exactly happens in our brains when we practice mindfulness? Studies utilizing functional magnetic resonance imaging, fMRI, have unveiled remarkable insights into the neural mechanisms activated during mindfulness meditation. Neuroscientist Sarah Lazar, from Harvard University, conducted a pivotal study comparing the brain scans of experienced meditators to those of non-meditators. Her findings were astounding. Individuals who regularly engaged in mindfulness practices exhibited increased gray matter density in regions associated with emotional regulation, memory, and empathy. Furthermore, mindfulness has been shown to effectively reduce anxiety and depression. In clinical trials, participants engaging in mindfulness-based interventions reported significant reductions in these symptoms compared to control groups. This suggests that the practice does not merely offer temporary relief but can lead to lasting changes in brain function, a reset for our minds. One remarkable case involved a group of veterans diagnosed with PTSD. After an 8-week mindfulness program, participants demonstrated decreased symptoms and increased emotional resilience. The transformation was inspiring, not just in their mental health but in their social interactions as well. But the benefits of mindfulness are not confined to mental health. Research reveals that regular mindfulness practice can enhance cognitive function as well. A study published in the journal Psychological Science found that participants who underwent mindfulness training showed improved attention and working memory compared to those who didn't. This indicates that by training our minds to focus on the present moment, we may enhance our cognitive capabilities in everyday life. In an age where distractions abound, social media, constant notifications, the pressures of life, mindfulness stands out as a refuge. Yet, while the scientific backing for mindfulness continues to grow, some skeptics argue that the practice may not be a panacea. Critics voice concerns about mindfulness becoming a trend devoid of its cultural roots, advocating that we must approach the practice with respect and authenticity. Despite these challenges, the growing body of research surrounding mindfulness presents a promising frontier for mental well-being. As we continue to explore and understand the intricate workings of the human brain, mindfulness offers a way to turn inward, cultivating awareness and nurturing resilience. In pursuing inner peace, we inevitably raise questions about our relationship with ourselves. Can enhancing our mental health through mindfulness lead to profound shifts in our identity? Each moment we take to breathe, meditate, and reflect may be a step toward mastering our minds and reclaiming control in a world filled with chaos. The journey is ongoing, the discoveries endless, as we unveil the mysteries of the brain, the answers may well redefine our understanding of consciousness itself. Decision-making is a fundamental part of human experience, yet the mechanisms behind it are still shrouded in mystery. Scientists have long been fascinated by how the brain processes options, assesses risks, and ultimately reaches conclusions. One of the first major studies on decision-making involved the Iowa gambling task, developed by Antoine Becquerel and his colleagues in the late 1990s. This task revealed how our brains utilize emotional feedback in decision-making, demonstrating that patients with damage to their prefrontal cortex struggled to make advantageous choices. The interplay between reason and emotion is critical here. The concepts of the dual process theory, where the brain engages both analytical reasoning and intuitive feeling, illustrate how complex human decision-making can be. These insights lead us to understand that decision-making is not merely a logical operation, it's an emotional experience, entwined deeply with our personal histories. One groundbreaking study in 2005 by researchers at MIT demonstrated that the brain values options based on past experiences and emotional responses, essentially creating a neural map of memories to guide future decisions. Understanding the neurology behind decision-making also opens a door to understanding abnormal behaviors, such as in addiction or compulsive behaviors, where the brain's reward circuitry hijacks the natural decision-making process. The ethical implications here are profound, as we begin to unravel the complexities of neuroeconomics, the intersection between neuroscience and economic behavior. As we delve deeper into the implications of these findings, the question arises, can we train our brains to make better decisions, or are we prisoners of our neural wiring? As technology continues to advance, its impact on our brains has become a hot topic of debate. The digital age has introduced a plethora of tools that alter not just how we interact with the world, but how we think, learn, and even perceive time. A significant body of research has begun to investigate how constant exposure to screens and the rapid-fire pace of information can affect cognitive functions. For example, studies conducted by the University of California, Los Angeles, suggest that heavy media multitasking can lead to a decrease in cognitive control. The brain's ability to filter out irrelevant information diminishes, making it harder to concentrate and retain information. One study even found that multitasking can reduce productivity by as much as 40%. Furthermore, our reliance on technology has profound implications for memory. This phenomenon, often referred to as digital amnesia, describes how our dependence on devices affects our ability to remember and store information. The concept of Google effects depicts how people are less likely to memorize information they can easily find online. In a study by Betsy Sparrow and her colleagues, participants were less likely to recall facts they believed they could look up again. This raises critical questions about how cognitive processes and memory formation are evolving with technology. However, it's essential to recognize that technology is not inherently detrimental. For instance, brain training apps have emerged that claim to enhance cognitive functions such as memory and attention. The key will be in striking a balance between utilizing these tools and ensuring we preserve our mental faculties. So, as we navigate a tech-driven future, the real question looms, will technology ultimately enhance or hinder our cognitive abilities in the long run? In recent years, the concept of neurodiversity has gained traction, challenging the traditional views of brain functioning and mental health. Neurodiversity posits that neurological variations, such as autism, ADHD, dyslexia, and others, are part of the natural spectrum of human diversity and should not necessarily be viewed through a lens of deficiency or disorder. This shift in perspective is not just political, it's rooted in science. One of the leading voices in this movement, Judy Singer, who coined the term neurodiversity in the late 1990s, argues that different neurological conditions can offer unique strengths and perspectives. For instance, individuals on the autism spectrum often excel in specific cognitive areas like pattern recognition and attention to detail, which can lead to impressive abilities in fields like science, technology, engineering, and math. Research highlights that neurodiverse individuals can contribute significantly to innovation and problem-solving when their unique strengths are recognized and harnessed. However, societal misconceptions can lead to marginalization, creating a need for inclusive environments that support diverse ways of thinking. For example, workplaces that embrace neurodiversity often report higher levels of creativity and productivity. Studies conducted by firms like SAP and Microsoft show how hiring practices that prioritize neurodiversity can not only enhance team dynamics but also drive business success. But as we advocate for neurodiversity, we must also address the challenges faced by these individuals. Access to appropriate educational and healthcare resources remains unequal, often limiting opportunities. As we ponder the future of neurodiversity, one pressing question stands out: can society truly embrace neurological differences, or will outdated perceptions continue to hold sway? Language is more than just a collection of words. It is the window into our thoughts, emotions, and culture. The human brain's ability to process and produce language is astounding. From the moment we learn to speak, our brains are hard at work decoding sounds into meaningful phrases. Researchers have identified specific regions responsible for language, notably Broca's area and Wernicke's area. But how do these areas work in harmony? Consider the story of a young girl named Sarah, who experienced a stroke that affected her speech. After months of therapy, she regained her ability to communicate, revealing the brain's remarkable capacity for recovery and adaptation. In this chapter, we will dive into the complex neurobiology behind communication, exploring how our brains translate thoughts into words, the impact of language acquisition on the developing mind, and how disorders such as aphasia can alter our ability to connect. We will also look at the fascinating relationship between language and thought, including the Sapir-Whorf hypothesis, which suggests that our language can shape our perceptions of reality. Finally, we will uncover the neural pathways that are activated during conversation, revealing how our brains synchronize with one another in social interactions, laying the foundation for empathy and understanding. But as we unravel the mysteries of language in the brain, we are left with a profound question: does language define our reality, or merely describe it? Trauma shapes our lives in ways we often cannot see, leaving indelible marks on our brains and behavior. Research has shown that exposure to traumatic events can lead to significant changes in brain structure and function. For example, consider the case of veterans returning from combat. Many experience symptoms of PTSD, such as flashbacks, heightened anxiety, and emotional numbness. Studies have revealed that these symptoms correspond with alterations in the amygdala, which governs our fear responses, and the prefrontal cortex, responsible for decision-making and emotional regulation. This chapter delves deep into the science of trauma and its effects on the brain, exploring how stress hormones like cortisol can reshape neural pathways, sometimes leading to long-lasting changes. We'll hear stories from survivors who have bravely faced their trauma and learned to navigate the brain's response to distress. We will also examine therapeutic approaches such as EMDR and cognitive behavioral therapy that have shown promise in rewiring the brain's response to traumatic memories. Ultimately, we will confront a challenging question: can the brain truly heal from trauma, or do we simply learn to live with the scars it leaves behind? The relationship between the brain and gut is a captivating area of neuroscience, one that merges biology, psychology, and even nutrition. Did you know that the gut is sometimes referred to as the second brain? This nickname arises from the enteric nervous system, a vast network of neurons embedded in the lining of the gastrointestinal tract. The gut communicates with the brain through the vagus nerve, carrying signals that can influence mood, anxiety, and overall mental health. One groundbreaking study discovered that participants who consumed a probiotic-rich diet reported lower levels of anxiety and depression. In this chapter, we will explore the science behind the brain-gut connection, examining how gut health can impact mental well-being and cognitive function. You'll learn about the role of neurotransmitters like serotonin, which is predominantly produced in the gut, and how this influences our feelings and behaviors. We'll also discuss the implications of the gut microbiome, the community of bacteria living in our intestines, and how a diverse microbiome is correlated with a healthier brain. Through stories of individuals who transformed their mental health by addressing their diet, we will uncover a compelling narrative that the path to mental clarity and emotional resilience may be rooted in the very foods we consume. Decision-making is a fundamental aspect of human behavior, influencing every facet of our lives. But how does the brain navigate such complexities? The prefrontal cortex, often dubbed the brain's executive center, plays a pivotal role in weighing options and predicting outcomes. A fascinating study led by neuroscientist Reed Montague at the Baylor College of Medicine reveals that our brains engage in a unique form of statistical reasoning when making choices. In a series of experiments, participants were asked to make decisions based on probabilistic rewards. The scans showed heightened activity in the prefrontal cortex, suggesting that our brains are not just reactive but are constantly predicting future consequences based on past experiences. This insight provides a glimpse into why some people are more risk-averse than others. Our decision-making processes are shaped not just by logic, but by emotional histories and neural pathways. Interestingly, the interaction between emotion and cognition is critical. The work of Antonio Damasio, a neuroscientist known for his work on the relationship between emotions and decision-making, emphasizes that emotions play a crucial role in our choices. He introduced the concept of somatic markers, which are emotional reactions that arise in response to potential outcomes. For instance, a person might feel nervous before